All right, philosophers, I want to give you a somewhat simplified method for doing proofs with implication rules. Now, doing proofs with this method requires you to know your rules really well. That's indispensable. But once you do know your rules, here is the method you can follow to do these. Now, I spelled it all out here so you can have it all in one place. I'm going to work you through each step of it in examples in one example. Now, this method is pretty much all you need to do proofs that only involve implication rules. Once we start throwing in replacement rules, that's going to add some nuances because they work a little bit differently, but the same basic structure is going to be the one you want to keep using for the rest of the semester. All right, so let's start with this example. Now you got the premises are numbered, and then the conclusion is given to you after the backslash. When I work these proofs, I do them on a piece of paper so I can leave myself a lot of room between the premises and the conclusion. And so I can work backwards from the conclusion towards the premises. And I don't know how much space I'm going to need. I don't know how many premises it's going to take. So I don't work directly from the program that we do our homework on because that forces me to go one line at a time from the premises downward. And that's not the way I want to think about it. So I do my answers on paper and then I transfer them back to my program. So you lay it out like this, okay? And now here's the first step. Look for the conclusion inside the premises. So my conclusion I'm going for is C. Do I see C inside any of the premises? The answer is yeah. I see it there in premise 2. It is the consequent of a conditional statement, right? Great. Now, my next step is this. I ask this question. What rule do I know that will let me prove my conclusion from that premise? In other words, what rule will let me prove C from premise 2? Now, let me think about it more concretely in terms of this particular example. Premise 2 is a conditional statement. The main operator is the horseshoe. C, which is my target, is the consequence of that conditional statement. So the question I'm asking myself is, what rule do I know that takes a conditional statement as one of its premises, and then it has the consequent of that conditional statement as its conclusion? Now, if you know your rules really well, that should be automatic. If it's not automatic for you, you got to get some flashcards out and study those rules more. It's got to be automatic. The answer is modus ponens. Modus ponens will take you from a conditional statement to concluding to the consequent of that conditional statement. So this brings us to step 3. What other premise, if any, do I need in order to apply this rule? Here's what I mean by that. Modus ponens, I put the form of it right here in the middle. If P then Q, P therefore Q. It takes 2 premises. Now, in my particular example of modus ponens, premise 2 gives me a conditional statement, the equivalent of if P then Q. In our case, everything that's in parentheses is the P, it's the antecedent, and the C is the Q, the consequent. And I've got the conclusion C, right? That's what I'm going for. But I'm missing a piece here, right? I need another premise. I need the equivalent of P. In other words, I need a line that tells me that the antecedent is true. Now, what is the antecedent that I need? What's the antecedent of this conditional statement? That's what I need. Well, in my particular case, the antecedent is everything that's in the parentheses there. If G, then not K. That is the other premise that I'm going to need to have. I'm going to need to prove in order to be able to validly use modus ponens to prove C from line 2. All right, well, where do we go from here? Well, what we're going to do is ask 2 questions. First of all, is that antecedent statement given to me somewhere in my premises already? The answer is no, it's not given to me. It's only there in line 2, and I can't get it back out of line 2, like double dip into it. So there's another alternative though, and that is B here. If you need a premise that isn't given to you already in what's been proven or stated, then just write that premise down anyway and figure out how to prove that by starting back at step one. What do I mean? Just write it right there. You're working your way backwards from the final conclusion to the intermediate steps until you connected the dots with the premises. Now we're just going to treat if G then not K as our conclusion and start right back over with premise one. Look for if G then not K inside the premises somewhere. And again, somewhere besides premise two itself. Do you see that? No, you don't. You don't see that whole mess in there. So now what do we do? If you don't see the whole conclusion in your premises, then look for the pieces. Do you see the pieces or the parts of if G then not K? Spot them? I see G in premise three, and I see not K in premise one. So that's where the pieces are. All right, well, where do we go from here? Well, you ask the same question as in step two. What rule do I know that will let me prove my conclusion from that premise? In this case, we've got two premises at play. Well, let me put it to you this way. What rule do you know that will give you a conditional statement as its conclusion? Because remember, the conclusion that we're going for, if G, then not K, that's a conditional statement. Do you know any implication rules that have conditionals as their conclusion? I can think of one. Let me give you another clue. What rule do you know that has two conditional premises and where the antecedent of one of those premises is identical with the consequent of the other? Here's what I mean. What's the antecedent of premise one? It's everything in parentheses here, M or R. What's the consequent of premise three? Oh, it's everything in parentheses here, which, fancy that, it's M or R. So I'm all set up to apply which rule? That's right, friends. Hypothetical syllogism. Yes, that's going to do it for me. So here's what we've got. Here's what hypothetical syllogism requires. If P then Q, if Q then R, therefore if P then R. Now in our case, the P is G, and the R is not K, and the Q is M or R. So here's what I've got. Do I have like a if P then Q? Yeah, line 3. If G then M or R. Do I have an if Q then R? Yeah, line 1. If M or R then not K. And so I've got everything I need already. I don't have to like posit another line. If you've got all the premises you need to prove your final step, you're done. All that's left is to just tidy up. Now, how do you tidy this up? Well, look what I did. I added numbers to all the lines. So I hadn't added numbers to this stuff before because I didn't know which number line they would end up being. I didn't know how many premises there would be. But now I can go ahead and say, okay, this is line 4 and this is line 5. And I also want to replace those question marks in the justifications with line number references. So I had a question mark here because I didn't know which line this premise that I needed was going to end up being. But now I see, oh, it's line 4. So I add back in 4. There you go. In other words, you're just going to apply my 4-step method, which is with this little codicils, over and over again until you get your answers. If you know your rules really well, that'll do it for you. Okay, if you get stuck, let me know. Happy proofing.